Assalamu alaikum. Today we will be solving May-June 2023 paper 4 2 theory extended total time 1 hour 15 minutes. Bismillahirrahmanirrahim. Let's start. Total marks 80. Okay, so first question. A list of oxides A to H is shown. Calcium oxide, aluminum oxide, silicon oxide, sulfur dioxide, carbon dioxide, iron 3 oxide, silver oxide, and carbon monoxide. Answer the following questions about the oxides A to H. Each letter each letter may be used once, more than once, or not at all. Okay, so state which of the oxides A to H is responsible for acid rain. So we know for acid rain we have oxides of sulfur and nitrogen, which are responsible for acid rain. In the air, they react with oxygen to form oxides, sulfur and nitrogen. Both when they enter the air, the atmosphere, they react with oxygen to form sulfuric acid and nitric acid respectively. Nitrogen needs lightning for reaction with the oxygen. However, sulfur does not. Now, what do we have in our options? We have only sulfur dioxide, so we will write the letter D. Next, this question, if I were to sum it up, this part A, B, C, D, E, F is 90% metals. You'll know soon enough. Part B has a giant covalent structure. We have three giant covalent structures with us, silicon dioxide. We have graphite and we have diamond. You need to know their properties, their structures, the bonding and structure, the bonding in it, the dot and cross, no, not exactly the dot and cross for giant. You need to know the dot and cross diagrams for simple molecules only. For giant, you need to know the strength of their bonds and whatever I told you. So what do we have here? We have only the oxide, silicon oxide over here. So we will write C. Next is a reducing agent in the blast furnace. So we have a series of reactions in the blast furnace in the extraction of iron. You have to memorize all the reactions sequentially, their features, their products, their reactants, the balanced equations, what is a reducing agent, what is an oxidizing agent, everything. What is a purifying agent, which reaction is thermal decomposition, every reaction you have to memorize. You can find all of it in the metals chapter, and most of it is given in the syllabus itself. This topic is best studied from the syllabus. Okay, so which is a reducing agent in the blast furnace? We know carbon monoxide. Carbon monoxide H. Carbon monoxide reacts with Fe2O3, the iron ore, to form Fe plus carbon dioxide. Next is the main constituent of bauxite. Bauxite is the aluminum ore. So the aluminum ore is obviously aluminum oxide, which is the letter B. E is the main impurity in iron ore. So the main impurity which we have to remove in iron ore is again silicon oxide, which is C. So this is what they said exactly. Each letter may be used once, more than once. So C is being used more than once. What is the reaction? SiO2 is reacted with calcium oxide, calcium oxide to produce calcium silicate CaSiO3, which is also called slag. Now, how did we get this calcium oxide? First, there was a thermal decomposition reaction in which carbon dioxide and calcium oxide were formed. From this, the calcium oxide reacted over here. Now, F can be reduced by heating with copper. Again, metals. The answer is silver oxide. Why? Because If you remember the metal reactivity series, if you remember that, we have copper above chlorine, above silver, and the metal which is above in the reactivity series can displace the metal which is below it. For example, we have potassium first, sodium, calcium, magnesium, zinc, and so on. We have hydrogen, then copper, and at the down at the bottom we have Ag. Not exactly at the bottom, but below Ce. So Cu can displace Ag and can be reduced. The reduced basically means can displace, because if you write the equation for the reaction Cu plus AgO, silver oxide, what will be formed if Cu displaces? CuO, copper oxide plus Ag. So if we look at the oxidation states, oxygen was -2 over here, silver was +2. Here, silver is a neutral element, so it has 0. So it is reduced, -2. And copper is a reducing agent. It itself has oxidized. Next, fluorine, chlorine, and bromine are in group 7 of the periodic table. State the name given to group 7 elements. We know this is halogens. Similarly, for group 1, this is the periodic table chapter. For group 1, we have alkali metals or white white salt. They produce white salt, so white metals. Explain why group 1 elements have similar group 7 elements have similar chemical properties. The chemical properties, the elements reaction with other elements, other atoms, other compounds depend on the number of outer shell electrons, because that is their valency, that is their charge, everything depends on it. Next, from atomic structure, this question. Oh, sorry, not this one. Ahead after this. This is from the same topic. Fluorine is pale yellow in color. Its state at room temperature and pressure is a gas. Chlorine is also a gas. Bromine is liquid. Beyond it, iodine is a solid. Chlorine has a color of yellowish green, greenish yellow. Bromine is reddish brown, and iodine is gray black solid. You know, you have to remember the trend. Also, the boiling points and melting points increase, the density increases, the reactivity, however, decreases. Bromine has two naturally occurring isotopes, 79 Br and 81 Br. State the term given to the number 79 and 81 in these isotopes of bromine. So we know this is the mass number or the nucleon number. Nucleon number. The number which will be written below, whatever it may be, 56, or for example, just for example, that will be the atomic number or the proton number. The smaller one is the proton number, the larger one is the mass number, because the mass number is sum of protons and neutrons. Next, this is from atomic structure. Number of protons in 79 Br. For this, it is better if we look at the periodic table at the last page. Br has 35 electrons, and the isotope which you are given in your syllabus is of 80 nucleon number. So the proton number remains same, only the mass number, the nucleon number, as the number of neutrons change within isotopes, but the atomic number remains same. This can also come as a separate question itself. So we have number of protons 35. We have number of protons 35. This you will always look from the periodic table. The number of protons or the atomic number or the number of electrons in a neutral atom. So protons will be, we just looked, I forgot. It was 35. Okay, 35. Protons, same here. Now, number of neutrons is the nucleon number minus the proton number equals to neutrons. So you just have to minus 79 and 35. You will get 79 minus 35, 44. 44, and over here you will get 81 minus 35, 46. Okay, now here it is neutral, so the number of protons will be equal to the number of electrons. So 35 electrons. Here, however, as you can see, there is a negative charge, which means that it has one more electron than it should originally have. So it originally had 35 electrons. So one more than that will be 36. Why one more than that? Because it has a minus one charge. It has gained an electron. This is not a bromine atom. This is a bromide ion having a charge of minus one. And all group 7 halogens have minus one charge. Next, table 2.3 shows the relative abundances of the two naturally occurring isotopes of bromine. Isotope of bromine 79, isotope of bromine 81. Relative abundance 55% of the 79 and 45% for 81. Calculate the relative atomic mass of bromine to one decimal place. Never ignore the instructions. One decimal place. They also have it highlighted for you. So the atomic mass will always be percentage abundance multiplied by the mass of one isotope plus the percentage abundance and the mass of the second isotope. This will always remain same no matter how many isotopes and their respective percentage abundances you have. So AR will be percentage basically means divided by 100. So we divide 55 by 100, which will give us 0.55 times the mass, which is 79, plus 0.45. The mass is 81. You can just calculate it to get the relative atomic mass. 0.55 times 79 plus 0.45 times 81, which is 79.9. Now, as we have to write to one decimal place, so this will be our final answer. Next, chlorine. Again, we return back to the periodic table. Chlorine displaces bromine from aqueous potassium bromide, but does not displace fluorine from aqueous sodium fluoride. So you should have significant practice enough to immediately form or immediately anticipate what the examiner is going to ask you next. First, they ask you the equation for the reaction between chlorine and aqueous potassium bromide, and they have told us exactly what will happen. Potassium bromide, the thing we have to do ourselves over here is decide the formula. We know potassium is in group 1, we know bromine is in group 7. So group 1 will have a charge of plus 1 as it needs to donate one electron to lose one electron to gain a fuller octet, and bromine needs one electron. So the charges will be plus 1 and bromine will have a minus. Cross multiply 1 over here, 1 over here, no effect. KBr will be the formula. Next, Cl exists as a diatomic gas. We should know that all group 7 elements, or we can say all halogens, are diatomic. In fact, all gases are diatomic except for the noble gases. All gases, H2, N2, every gas is diatomic except for the noble gas, of course. Now, Cl will displace bromine from here. It will become KCl, the same formula as it is also in the same group, plus Br2 will remain over here like this. Now we have to balance this as well. So we can see 2Br over here and 1Br over here. If we add a 2Br on either side, now we have 2Cl. We can add 2Cl over here, which will automatically balance the potassium itself. Next, state Y chlorine. This is what I was talking about earlier. State Y chlorine does not displace fluorine from aqueous sodium fluoride. This is what they told us earlier. It does not displace because, as I told you earlier, the reactivity down the group decreases. The reactivity down the group decreases, so chlorine is less reactive than fluorine. Fluorine is the most reactive element from group 7. Next, aqueous silver nitrate is a colorless solution containing Ag plus ions. Describe what is seen when aqueous silver nitrate is added to aqueous sodium chloride. So the formula for silver nitrate will be Ag plus, means it has plus one charge, and nitrate ions, we have to memorize this as we will not find this in the periodic table. So Ag has plus, NO3 has minus, cross multiply again, AgNO3. Similarly for sodium chloride, plus minus, which will give us NaCl. So AgNO3 plus NaCl. Okay, so we don't have to write the equation over here. My bad. We will do this afterwards. First, we have to decide in theory what will be produced. As I said, describe what is seen when aqueous silver nitrate is added to aqueous sodium chloride. So let us first do the equation. Then we can do this. Then I will be able to explain it better. Okay, so when AgNO3 reacts with NaCl, Ag is the positive over here. This is the negative. This is the positive. This is negative. The negative, the positive is bonded with the negative over here, and this positive binds with this negative. So this will give us AgCl, or we can write over this side AgCl plus NaNO3. Now the thing is, AgCl is silver chloride, and this is an insoluble salt. This is what you have to memorize. The insoluble salts, the soluble salts. For sulfates, for carbonates, for nitrates, for chlorides, for bromides, for iodide. You have to memorize this. Chlorides are silver chloride at least is insoluble. Similarly, lead 2 chloride is also insoluble. All other chlorides are soluble. As for nitrates, nitrates are always soluble. Sodium, potassium, ammonium. Any salt, if they are present in any salt, that is soluble. As for nitrates, nitrates are always soluble, and carbonates are always insoluble except for sodium, potassium, and ammonium. Now, all of this, don't panic. You can find all of this in your syllabus, notes for qualitative analysis, which is mostly used in P4, P6, but they also ask you in P2 and P4. So it's better if you memorize it, or I should say it is mandatory for you to memorize it. So what is seen? This is insoluble and its color is white. So white precipitate is seen. White precipitate. Next, the equation, and we have to include state symbol. It is for 3 marks. So there's the state symbol should be present correctly, the product should be mentioned correctly, and the state and the balancing should be correct. So if we do this, we know that this is aqueous as this is soluble, and they have told us this is also soluble, so this is aqueous. However, AgCl itself is insoluble. We just recognized it, and it is solid. As for nitrate, it is soluble, of course, aqueous. So all aqueous separate into ions. I am doing this in baby steps so you can understand. Otherwise, it is just a 2-minute work. So Ag plus aqueous, all aqueous ions separate, NO3 minus aqueous. We will do the balancing at the end. Plus Na plus aqueous plus Cl minus aqueous. This will give you AgCl will not separate as it is solid, plus Na plus and NO3 minus, it is both are aqueous, so they will separate. Now the aqueous on both sides will be cancelled, having the same charge and of course the same element. So nitrate over here can be cancelled. Similarly, sodium over here and sodium over here should be cancelled. What remains is Ag plus aqueous plus Cl minus aqueous. It will be AgCl solid. Now this, if you have enough practice, you can just memorize this and you will be able to write this straight away. Now, what these cancelled things are just the spectator ions. This is what we call them, spectator ions. They don't directly participate in the reaction. Next, over 200 million. Oh, I guess we missed one part. No, we have done this. Next, over 200 million tons of sulfuric acid are manufactured every year. State the name of the process you use to manufacture sulfuric acid. We know this is contact process. Now, contact and Haber, you need to know both of these. You need to know the favorable conditions. You need to know that these are equilibrium or these are, sorry, reversible reactions in which the equilibrium is affected by various factors. The rate of reaction is also affected. You have to remember all of it. And you have to remember the raw materials, the source of the raw materials. For example, sulfur dioxide is a raw material for sulfuric acid. So you have to know the source. Similarly, for nitrogen and hydrogen while manufacturing ammonia, you have to know the source of them too. So they're asking for two methods by which sulfur dioxide is obtained. So sulfur plus oxygen will give us sulfur dioxide. This means that burning sulfur in air, and next is roasting sulfide ores. You just have to memorize this. No equation is needed, however. Just have to memorize this, and it comes as it is in the exam for either ammonia, for either sulfuric acid, for either, yeah. So next, the conversion of sulfur dioxide to sulfur trioxide is a reversible reaction which can reach equilibrium. State two features of an equilibrium. Pure theory, we know that rate of forward reaction is equal to the rate of backward reaction. Backward reaction. Next, the second feature is of an equilibrium, of a dynamic equilibrium, that the concentration of the reactants and products do not change. Of reactants and products do not change, or you can write are constant, are no longer changing, whatever. This does not mean that they have equal concentrations or they have equal volume. No, this means that whatever concentration they have at equilibrium, it won't change now as long as equilibrium is maintained. This is what it is because the reaction is not moving over this side, nor is it moving over this side. Next, state the typical conditions and name the catalyst used in the conversion of sulfur dioxide to sulfur trioxide. This is pure recall. Temperature is 450 degrees Celsius, or and pressure is 200 kilopascals. Catalyst V2O5, or you can write vanadium 5 oxide. You don't need to remember the chemical formula. Vanadium 5 oxide. For ammonia, if this question were about ammonia, this would have been 20,000 kPa, and this would have been iron. Next, complete table 3.1 to show the effect, if any, when the following changes are applied to the conversion of sulfur dioxide to sulfur trioxide. The forward reaction is exothermic. Make sure to read through the entire question carefully because this is a piece of crucial information. Sometimes it may be given to you like this, minus 98, as this is exothermic, so this should be negative. Next, only use the words increase, decrease, or no change. So if if you see the February March paper for this same year, this is exactly the same question, just the difference is that this is related to sulfuric acid or the sulfur trioxide formation stage, while that was related to ammonia formation. Now, change is temperature. When temperature is decreased, what will be the effect on the concentration of equilibrium of sulfur trioxide at equilibrium? So to find out the concentration of sulfur trioxide, whether it increases or decreases, we first have to know where the equilibrium shifts, to the right or left. If it shifts towards the right, we know that sulfur trioxide will increase. If it shifts to the left, we know the sulfur trioxide will decrease. So it's a pretty straightforward question. Temperature decreases. This is an exothermic reaction. When the temperature decreases, the equilibrium moves forward. If they ask you a reason for this, you just write the forward reaction is exothermic. That's why when temperature is decreased, the reaction or the equilibrium shifts towards the right. So sulfur trioxide concentration increases. Now, next, the pressure, the effect on the rate of the forward reaction. When you apply more pressure on gases, the particles come closer together and there is a chance of more successful collisions, more effective collisions. So the rate will increase. Next, no catalyst. Catalyst has an effect on rate of reaction, but it does not have an effect on equilibrium, so no change. Next, explain in terms of collision theory why reducing the temperature decreases the rate of the forward reaction. Now, there is one thing which many students confusing the rate of reaction with the equilibrium. The temperature, no matter how it affects the equilibrium, the effect of reducing temperature on the rate of reaction will always remain same. It can vary on the equilibrium, whether the equilibrium will shift or right, but depending on the exothermic or endothermic nature of the reaction. But whenever we reduce the temperature, whether the reaction is going backward or forward, right or left, the rate will decrease. And whenever we increase the temperature, the rate will increase. If you're talking about the forward reaction, then yes, it will increase in this case because this in this case the equilibrium is shifting towards right. Now, why does it decrease the rate? We have a standard answer for this. For catalyst also, for temperature also, you should know all of it. It always comes for 2 or 3 marks or 4 marks. So when we decrease the temperature, actually, what happens is, now notice that the reaction is shifting towards the right. The equilibrium is shifting towards the right. That's why we increase the concentration of sulfur trioxide. So the reaction is moving towards the right, but still the thing is that the rate of the reaction is decreasing because the temperature is decreased. The equilibrium moves right, but the rate decreases. Now, why does this happen? We know that when temperature decreases, the kinetic energy of the molecules of the particles decreases, and this would have been vice opposite if the temperature was being increased. Energy of particles decrease, they move slowly, the frequency of collisions decreases, there are fewer successful collisions or frequency of collisions between particles. And next, when we decrease the temperature, less particles have enough energy to react. Now listen to this carefully. When we reduce the temperature, less particles, fewer particles have enough energy to react. Now, what is this enough energy to react? This is the activation energy of the reaction, the minimum energy for particles to start to collide effectively and to form and to react actually. So, this energy is provided by increasing the temperature to the particles so that they can reach this threshold point. When this temperature is decreased, so it is obvious that fewer particles or fewer percentage of particles have energy above the activation energy or equals the activation energy. What a catalyst's job is to reduce this activation energy itself. It does not provide activation energy to the particles, rather it reduces that threshold point to needed to react. Now I notice we left this. What is happening? Pressure is increasing. So when pressure is increased, what happens to the equilibrium? It depends on the number of moles of gas. number of gas moles. When pressure is increased, side with fewer gas moles is favored, meaning that the side having fewer gas moles, the equilibrium shifts to that side, which has fewer gas moles. If pressure is decreased, however, pressure side with higher gas moles is favored. Now, what will happen in this case? We have a total of 2 moles of gas over here. We have a total of 3 moles of gas. We are increasing the pressure. Once you have decided this, what will happen to the equilibrium? You can easily relate it to the question itself. We have fewer moles over this side, so equilibrium will shift to that side. If this was a theory question, I mean, not in the form of a table, and if it were requiring an explanation, you would have written that there are fewer moles of gas on the right hand side, so the equilibrium shifts towards right, and thus the sulfur trioxide concentration is increasing. So I'm telling you the various ways it can be asked. Next, sulfuric acid contains SO4 2 minus ions. Radical, yes. The oxidation number of O atoms in SO4 2 minus ions is -2, of course. Determine the oxidation number of S atoms in SO4 2 minus. Show your working. So whenever you have this statement, you have to show your working, no matter how easy the question is. So this 2 plus indicates that the total charge on the entire molecule is 2 minus, which means that adding the oxidation number of sulfur plus adding the total oxidation states of oxygen. So one oxygen is 2 minus. We have 4 oxygens will be equal to -2. If there were no -2 over here, this would have been equal to 0. But as we can see, there is a -2 over here as it is a charged molecule. Otherwise, we have compounds like H2SO4 in itself is a neutral compound having no net charge on the entire compound. So this will be 4 twos are 8, sulfur plus or -8 equals to -2, sulfur equals to -2 plus 8, sulfur equals to plus 6. Pretty easy. Next, acid basis salt. Solid sodium hydroxide is a base which dissolves to form an aqueous solution NaOH. State what is meant by the term base. The base, as it is most of the definitions are written in your syllabus itself. Be sure to read through the entire syllabus, or if you're studying topic wise, study the topic first from your course, from your notes, from your textbook, then go to the syllabus and place a check in front of each learning objective, each learning outcome as you read it. If you know it better, if you know it, if it comes to you as a question, you can answer it very well. So, what is meant by the term base? Bases are proton acceptors. Now, you might be thinking proton is not donated, is not gained. This proton means hydrogen in this case, as the composition of hydrogen is the same as proton, as hydrogen does not have a neutron and it only has plus charge. So proton also has a plus charge. So proton acceptors, this basically means that if we have NaO plus H2, this will become NaOH, as we know. So what has NaO done? It has gained a hydrogen atom. So this can be tested in various ways. We just have to know the definition at this level, though. State the term given to a base which dissolves to form an aqueous solution. We know what it is. It is an alkali. The bases which are soluble in water and form to make an aqueous solution, they are called alkalis. State the color of thymophthalein in NaOH. Thymophthalein is blue in alkalis and colorless in acids. You need to remember this. Complete the word equation for the reaction of NaOH with ammonium chloride. So as we have this reaction, we have another reaction of acid plus carbonate, which releases carbon dioxide plus water plus salt. Why did I write this? Because these two are similar in a way that they are separate or they are different from the normal reactions which we have for acids and bases. Acids and bases both react mostly to form salt and water or salt and hydrogen, but in this case we have a gas. Here also we will have a gas, ammonia, and water and a salt, sodium chloride. Next, some metal oxides react with NaOH. Now, NaOH is a base, and all metal oxides are also supposed to be bases. Metal oxides are bases, but there are another class of metal oxides we have studied, which is amphoteric, which react with both base plus acid. They react with both, as they have both dual nature, you can say. So the metal oxides which react with bases are amphoteric. Name a metal oxide which reacts. We have two in our syllabus: aluminum oxide, aluminum aluminum oxide, or we could write zinc also, zinc oxide also. So amphoteric means it reacts with both a base and an acid, because a substance which is entirely acid, it only reacts with the base, because same nature substances do not react. A metal cannot react with a metal, you know that, but a metal can react with a non-metal. Similarly, an acid cannot react with an acid itself, but a base can react with an acid. And a base cannot react with an base. A base can react with an acid. So this explains the amphoteric behavior, that aluminum oxide can also react with NaOH, and aluminum oxide can also react with HCl, for example, which is a acid. Next, we have a dot and cross in front of us. Ethanoic acid is a weak acid. Complete the dot and cross diagram in figure 4.1 of a molecule of ethanoic acid. So, for completing a dot and cross, we need to show the number of electrons bonded and the lone pairs. So, for that, first, it is better if we draw the structure itself, the displayed formula. CH3, it is written in the stem of the question. COOH, the functional group of the carboxylic acid. So, a single bond with all three hydrogen, and the electron of a carbon should be mentioned with a dot and cross. For hydrogen, hydrogen does not have a lone pair, as it only have one electron. Similarly over here, so, and with the other carbon also, the carbon has single bond. So this gives us 1, 2, 3, 4 originally, which were carbon atoms, electrons, and 4 from another atom. Now here we have a double bond, and here we have a single bond again, as oxygen is bonded to hydrogen with a single bond as well. If we draw this as this. Now, the one mark which still remains is of the lone pair of electrons of oxygen. So oxygen is denoted by a dot, this carbon with a cross. So oxygen should have total of 6 of its own electrons in its outer shell. Total 8 electrons and 6 of its own. So we need to draw 6, 2, 4, and 2 we had already drawn. So giving us 2, 4, 5, 6, and 2 from carbon, 7, 8. Similarly for this oxygen, 1, 2, 3, 4. Total of 6 own electrons of oxygen and 2 borrowed or shared. Suggest the pH of dilute ethanoic acid. We know that this is a weak acid. As what is the reason behind this, and what is the definition of a weak acid? Which undergoes partial dissociation of H plus ions in aqueous solution. So that is a weak acid. And here it is already dilute, so the pH will be very near to the neutral pH. We can write 5. Complete the simple equation to show the dissociation. Dissociation means donation of H plus ions. So CH3COOH will dissociate into CH3COO plus H plus, and this will be minus. This is a reversible reaction, as this hydrogen can be gained again by the acid. Next, write the ionic equation for the reaction when acid neutralizes a soluble base. This is always the same. You don't have to make an acid, especially. This will always remain the same. This will always remain the same. H plus OH minus ions will be forming a water molecule. Next, this is of moles, a titration flavor question. In a titration 25 cm cube, this should be 0.025 dm cube of 0.080 mole per dm cube aqueous potassium hydroxide is neutralized by 20 cm cube, which is 0.02 of dilute sulfuric acid. So remember to read the question twice at least so that you know which information you are given, which information you are being asked. Carefully look at the equation. Calculate the concentration of H2SO4 in grams per dm cube using the following steps. Now the final outcome is the grams per dm cube one, but we are going in steps. These are guiding steps for us, the building blocks. Calculate the number of moles of KOH, which is potassium hydroxide. We know the formula of number of moles for KOH being given the number of the concentration and the volume. We have a formula N equals to CV, where N is the number of moles, 0.08 times 0.025. Be sure to convert it into dm cube. Now you can use a calculator, and to find out the answer, you will get 0.002. Next, determine the number of moles of H2SO4 which react with the KOH. Now we know, according to the balanced equation, if there are 2 moles of KOH, they need 1 mole of H2SO4, which means that we will divide or halve the number of moles of KOH to get the number of moles of H2SO4. Simply put, 2 is to 1 is the ratio. So when we have 0.002 moles of KOH, this will be X. We can cross multiply it. The answer will be 0.002 over 2. This is what I said earlier. You have to show that you're working. This will give you 0.001, of course. Now, calculate the concentration of H2SO4. We know the volume of H2SO4. We can calculate the concentration with this same formula. Concentration will be N over V equals to number of moles are 0.001 over volume is 0.02, which will be 0.05. You can also write it 2 times 10 to the power minus 3 and 1 times 10 to the power minus 3 and 5 times 10 to the power minus 2. Both are correct. Now, this was in moles per dm cube. Calculate the concentration of H2SO4 in grams per dm cube. So we have to go from moles to grams because dm cube is the same in both. So what do we do when we go from moles to gram? For example, we use the formula N equals to G over mR. G is the mass in gram. So if we want to know this, if we want to know the gram from the moles, if we are given the moles of a quantity of a compound and the mR, and we want to know the gram, what will we do? We will just multiply by the mR, the number of moles. So the number of moles of H2SO4 was 0.001. But what we have to do is the concentration of 0.05, we have to multiply this by the MR. The MR is, if we look at the periodic table, you will find sulfur is 32. So 32 plus 2 for hydrogen plus 16 times 4 for sulfur. This should give you 98, the MR of the molecular mass of H2SO4. When we multiply this, we get 4.9 grams per dm cube. This is what the final outcome was desired. The concentration of H2SO4 in grams per dm cube. It's really simple, simple formula, simple ratios, nothing complicated. Next, organic chemistry starting from here. Propane and propene both react with chlorine. When a molecule of propane reacts with chlorine in the presence of UV light, we know what this is. One atom of hydrogen is replaced by one atom of chlorine. State the term given to reactions in which one atom in an alkane is replaced by another atom. It is substitution, of course, because it is replaced in place of hydrogen. There comes a Cl. Next, state the purpose of UV light because it has to provide the activation energy so that particles can react. State the term given to any reaction which requires UV light. This is also pure recall photochemical reaction. We have the substitution of alkanes with chlorine as a photochemical reaction. This is the UV light is required because the carbon-carbon single bond is very strong and it does not break easily. And apart from the bond itself, the molecule is a saturated one, so it is not very reactive. So next is write the symbol equation for the reaction between propane and chlorine. So propane is C3H8, I guess they told you. Yes, C3H8 plus Cl2 will give you when one Cl comes in place of one hydrogen, this will be C3H7. There are a series of reactions which end up like this, but you do not have to remember all of them. Just this equation will suffice. And the remaining, the one Cl which remained, as these were two chlorine atoms. So one combined with this, and when this hydrogen left, so this reacted with the Cl forming HCl. There is a mark for this as well. Next is a molecule of propene is unsaturated and will react with chlorine at room temperature. State why propene is an unsaturated molecule. A saturated molecule is the one which contain no double bond. As for unsaturated, they contain a double bond. They propene contains carbon-carbon double bond. So this double bond can be broken easily. Give the structural formula of the product of this reaction. When alkene react with any halogen or chlorine in this case, the product is dibromoalkane or dichloro in this case. If this was bromine, it should have been dibromoalkane. What this alkane is, this depends on the number of carbon in the alkene. So for the structural formula, we should know the structure, of course. CH3, CH2, and CH3. This is the structure of alkene with the double bond on one of the carbons, and two chlorines attach themselves to each of the carbon containing the double bond. When this double bond breaks, one chlorine comes here, one chlorine comes here. This will give you C. This was originally CH2. Let me draw the displaced formula for more clarity. CH3, C double bond CH, and this was also an H. Now when chlorine came, it came over here and it came over here. No hydrogens will reduce, just this double bond will break. So now we can write the structural formula CH3 and CHCl and CH2Cl. We can write this over here, CH3, CHCl, CH2Cl. Next, this is, by the way, an addition reaction in which a double bond is broken. Next, propene undergoes addition reactions with steam. There are two possible products, A and B. Draw the displayed formula and name each product. Displayed formula of product A, displayed formula of product B, and their names. So we know this reaction, addition of steam to An alkene gives us an alcohol, but the alcohol depends which double bond is broken and which has an OH attached to it. For example, the water contains two like this, OH minus and H plus. If we draw the alkene initially, the propene, it will be like this. These are all hydrogen branches. Now, when OH comes, whether it will attach to this, and when the OH comes, whether it will attach to this, or vice versa. Whether this OH will be here and this H will be here. So first we can draw this over here as they asked for the product A and name it then C H H H C H H. The what this depends on whether the OH will come on this carbon or that carbon. You don't have to know this at this level. Name of product A is, we know this is propan 1-ol, as the OH is on the carbon number 1. The numbering always starts nearer which from the carbon which is nearer to the OH or the functional group. Next, if OH comes on the second carbon over here and the H goes over here, this will give you, and this double bond has broken. Sorry, this double bond has broken. So this will be propan 2-ol. Okay. Next, carboxylic acids can be converted to esters. Name the ester form when butanoic acid reacts with ethanol. The formula is given. We know when writing the name, we write in this form that first alcohol name comes depending on the number of carbon. Everything else remains the same. Ethyl butanoate will be the name. If this was propanoic acid, just for explaining things, and this would have been maybe pentanol, and the ester would have been forming between them with a condensation reaction. We would have named it like what? You should guess it yourself too. Pentyl propanoate. Okay. Next, identify the other product form in this reaction. Water is the product as this OH and this H is what come together and are eliminated from the molecule. And as I already told you, OH and H both make up water. This is why this is called condensation. Reduce the empirical formula of the ester form. Now, the empirical formula is the simplest whole number ratio of an atom of atoms in a compound. So, what will be the formula of the ester? First, we have to know this. Or what will be the total number of carbons? The of the total number of carbons will be the same: one, two, three, four, five, six, because this will join itself, right? So the carbon number of this acid and that alcohol will add. So 2 plus 4 equals to 6 carbon atoms. So if we write the molecular formula C6, how many H's? 3H over here, 2 over here, 5, 6, 7. This will go, and 10, 12. This will go as well. So 12H, and how many O? 1 and 2, as this will go. So 2O. Now, if we simplify this, dividing all of them by 2, C3H6O. C3H6O is the empirical formula. Next, PET is a polyester. This means that ester bonds are present and many ester are formed, and the monomer itself is an ester. However, there are two different monomers for PET. Part of the structure of PET is shown. Circle one repeat unit of this polymer. We can easily circle this. We can see that if we see the entire chain, it starts from here and till here it is different, but after this it repeats again. This and this are exactly identical. So we know that the repeat unit is up till here. As after this, this is the same repeating over and over again. Draw the structures of the monomers which make up PET. Draw the functional groups. Draw the functional groups using displayed formulae. Now, we have two monomers. There is supposed to be a diol and a dioic acid. Now, using this key, we have to keep the shaded and unshaded version correctly. If this is the carbon chain in the middle and these are both acid groups on the sides, just like it was given above. So this will be shaded as they shaded the carbon containing the acid containing chain or the monomer. The next monomer is the diol, which means that it has alcohols on both sides. As we know, this is a polyester, means that acid and alcohol are reacting over here. So OH and OH, not shaded. So when the ester was formed, this OH and this H were gone. That's why you cannot see them over here. This O is from the carbon double bond. This indicates that it is from the acid, and this is from the alcohol. Now state the type of polymerization used in making PET. We know that when water is formed or eliminated, this is condensation. When no molecule is formed and a double bond is broken, it is always addition, which occurs in alkenes. So this is it. We have completed the paper. Alhamdulillah. Thank you.